here we go. We've got 2.5b to do. And we're going to continue finding zeros, okay? We're going to focus mostly on complex zeros. I think I've got like 4 examples. They take a while, though. They're a good quality over quantity, which should be your dating life, right? All right, here we go. Number 1.
What do you mean by quantity?
Quantity? You don't want a whole bunch of people. You want a really good quality person. All right, here we go. Number 1. What we're going to do is we're going to take a polynomial, f of x, and it's already in factored form, but we're going to get it into its regular polynomial standard form. Yeah, because a lot of people are leaving, including yourself, for the pep assembly. Okay, so here we go. We want to get this polynomial in the standard form, so we're going to do what? FOIL. FOIL, the opposite of factoring. FOIL, everyone's favorite 4-letter F word. Okay, here we go. X times x is x squared. That's on my video. I'm going to get fired now. And then minus 2xi and plus 2xi and then minus 4i squared. Okay, now what's going to happen is these polynomials don't have any i's in them. They're like hidden in there. Once you factor them, you see them. But here they're going to cancel out. And everyone knows that negative 4i squared is what? 4. And so that would be your polynomial. Right? And that makes sense because yesterday we factored it. Today we're foiling it. So pretty cool. Okay, let's do a harder one. Number 2. Same idea, but this time I'm going to have 3 factors. So here we go. F, yeah.
Is this the whole lesson?
No, there's lots of stuff. There's a really hard one at the end. Should have started with that one, huh? X minus 3. I'm sorry, x minus 5. X minus 5, don't write 3. X minus 5, and then times x minus rad 3i and x plus rad 3i. By the way, sometimes I would like to write I before the rad 3, but just know that it's never underneath the radical. It's always on the outside of it, okay? It could be super close. So we need to do the same thing. We need to get this into standard form, so we're going to FOIL. And here's what you want to do. You want to take these 2 first. If you FOILed, can you imagine FOIling this one and this one together first and all that nasty stuff in there? No, you don't want to do that. You would? No. Always FOIL the conjugates together because all the i's are going to drop out. It makes it a lot easier. All right, so what do we get here? We get x times x is x squared. The outside term is going to be a positive rad 3xi. Yeah? The inside term is a negative rad 3xi. Ooh, that's exciting. And then what's negative rad 3 times positive rad 3? That would be a negative 3i squared. Did I do it right? We're okay? All right, so I'm left with, still have x minus 5 here. And once I clean all this up, these reduce or cancel out. And then you get x squared plus 3. Okay. And doesn't it kind of make sense now that you look back and you go, oh yeah, that factored is going to be that because it's negative and it's going to be rad 3. All right, and then we go ahead and we FOIL it out. So I'm going to go x times x squared is x cubed. Outside gives me 3x. Inside is negative 5x squared and minus 15. You should technically rearrange those. Standard form is descending order of exponents. And that would be the whole thing. There's your polynomial. And you can tell what the zeros are when it's all in factored form from the beginning. All right, super fun, right? Let's do a hard one now. Okay. Those weren't hard ones, no. Number 3. Suppose that we are given zeros, and the zeros that we're given are negative 3 and 2 minus I and 2 plus I. Okay? remember, they always come in pairs. So if they only gave you 2 minus I, then you would have to then say, oh, 2 plus I is also a 0, okay? They always come in conjugate pairs for complex numbers. We're going to do the same thing. We're going to find its standard form polynomial, okay? So first thing we're going to do is we're going to put this into factors, the factors that go with these zeros. So my first factor for -3 would be x plus 3, right? It's always a minus and then the number. So knowing that it's always a minus and then the number, this is going to be x minus 2 minus I, right? And x minus 2 plus I. Okay? That confuses people sometimes because they think one should be minus and one should be plus. But you're really subtracting the whole thing. You're subtracting that whole thing. So let's rewrite this so that it looks a little nicer without all those parentheses in here. So distribute the minus to both terms. And you get x minus 2 plus I. And then you get x minus 2 minus I. Okay. Now this is a pretty bad problem. So now what you're going to do is you're going to FOIL. And we're going to take these two first over here. And you're going to do super FOIL. Okay? And it's actually kind of fun, though, because a bunch of stuff's going to cancel out, which is really exciting. So here we go. X times x is x squared. So I'm taking this x right here in the first spot, and I'm distributing it to all 3 terms in the other one. So x times x is x squared. And then I have a minus 2x, and then a minus ix. Is everyone okay with that first step?
Yeah.
I messed up this one so bad earlier, but people caught my mistakes before I really ruined the problem. All right, now let's take -2 and multiply that in. So I get -2x. -2 times -2 is positive 4. And -2 times -I is positive 2i. Okay, so I took the middle term and distributed it to all 3. Now take the last term, which is I, and distribute that to all 3. So I get ix, positive ix, a -2i, and a -I squared. Okay. That was fun. Yeah, love it. Now let's start canceling some stuff, right? I've got a -ix and a positive ix. Those are gone. What else can I cancel? I've got a 2i and a -2i. And so now what I end up with is x squared, and then I have a -2x and a -2x give me -4x, good. And then I have a positive 4 and a -I squared, which is really 1. And so I get +5. Amazing. Now we're going to take that and multiply it times x minus 3. Plus what? Oh, whoopsie woo-boos, yeah. +3, thank you. Just right in time, too. It's weird, I feel like it's Monday. I'm making all my Monday mistakes today. All right, x times x is x cubed. X times -4x is -4x squared. And x times 5 is positive 5x. Okay, one more time to super FOIL. 3 times x squared is 3x squared. 3 times -4x is -12x. 3 times 5 is 15. Did I do all that right? I messed up there too earlier. Okay, let's combine all our like terms and then we'll finally be done with this problem. So our polynomial, f of x, is equal to x cubed. How many x squares do I have? Good. Minus x squared. 5 and -12x is -7x plus 15. There it is. And you should expect a cubic because we started with 3 zeros. And then that's what it would be. All right. One more. And the last one's the best one. Here we go. Number 4. The best one. Save the best for last. All right, here we go. So we're going to be given a polynomial. This is going to bring it all together. So here it is. 3x to the 5th. Are you leaving right now?
Yeah.
Oh, you're missing. All right, all you have to do is watch this one now. Okay. So minus 2x to the 4th plus 6x cubed. Yeah, this is the last question of the lesson. We learned most of it 2 days ago. Minus 4x squared. I'm running out of room here. Minus 24x and plus 16. No. Okay. So here's what you do. We are going to find the zeros, and then we're going to write this in its linear factors. Linear factors means that nothing's squared. They're all just written out. Okay? Did you know that in your book it says the gray background numbers that you do are solved without a calculator? And the ones that don't have that gray background, you're allowed to use your calculator. This would be, this would be a calculator problem. Okay, so your first step, step number 1, is you need to graph this. Okay? Now, I already have it on my calculator because I graphed it earlier today. So let's just, if you want to also, you can type it in. But let's go ahead. I'm going to show you what the graph looks like. Here it is. Okay, so what this does, yeah, it's pretty ugly, is it goes like this, this, and this. And so what it did right here is it found three real zeros. Okay? Now, I'm not saying they're rational, but they're 3 real zeros. That means that there's how many complex? 2. Perfect. There's 2 complex zeros. They have to add up to 5. Okay? So I'm going to go ahead and see what these zeros are. Okay? So I always have y equals 0 stored in for y2 so that I can find the intersect. So calculate the intersect. And it ends up being 1.414. Does anyone other than Bobby know what that is? Yes, it is. It's rad 2. You were guessing. That was a good guess. All right, this right here is rad 2. Now let's say we don't know that. We don't have to know that, okay? This one over here, you know what that is? It is. It's negative rad 2. Okay, but I'm not even going to use that. I can tell on the graph, like, if you get some gross decimal like that, it's pretty bad. Now let's calculate the other one. Enter, 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 and I get 0.6 repeating, which is what? 2/3. Okay, that's the one I'm going to use. I'm going to use that rational. That's a rational number. The other 2 are irrational, and then my other 2 will be complex. So I'm going to use 2/3, and I'm going to get this down. I'm going to synthetic divide it and do all the thing, okay? So 2/3 on the outside with this big ol' x to the 5th here. So we have 3, -2, 6, -4, -24, and 16. All right? Okay, here we go. It's going to work out nice. What are we going to get at the end?
0.
We will. We will get 0. Okay, bring down the 3. 3 times 2/3. Nope. Try again. No? 2/3 times 3? 2. 2, thank you. -2 plus 2? 0. Oh, don't you love 0? Yes, except when you look at your bank account. Yeah, really. All right, 0 times 2/3 is 0. Add and you get 6. 6 times 2/3? 4. 0. Love you, 0. 0 times 2/3 is 0. -24. -24 times 2/3? -16. Yeah, it has to be, right? I know, without even knowing it. Okay, so what we just got was we got 3x to the 4th. Okay, we took a 5th degree polynomial, divided one of its factors out, so it's 3x to the 4th. You do not have to write 0x cubed, plus 6x squared. There's a 0x in the middle, and then minus 24. It is nice. So we're going to factor this guy. We're going to factor out a 3. Oh, it's going to be so good. Factor out a 3. Okay, that makes it much nicer. And then you want to factor again. Okay. So this is going to be x squared and x squared. And what times what is -8 and adds up to 2? +4 and -2. Okay. And now we're going to put everything together. All right. So the first part was to find the zeros. So I found that my 0, I had 2/3. Okay. And now from this factor right here, my zeros would be what? Anybody know? Just by looking at it. Subtract 4 to the other side. Take the plus and minus square root. 2i. That's where your complex ones come from, plus and minus. And then we already found this one, right? X squared minus 2. Andrew knew that one. X squared equals 2, so plus and minus rad 2. Those are the 5 zeros of this polynomial. Pretty cool, huh? 1 rational, 2 irrational, 2 complex. Now the second part was to put this into its factored form. Okay, do you see this 3 right here? Yeah, you kind of need to use that. You know this x, or this 2/3, you're not going to write x minus 2/3. You're going to take that 3 and multiply it by there. Because what happens, you get 3x minus 2. Isn't 2/3 a factor of, yeah, it's a 0 of 3x minus 2. That's where this 3 comes from. You just multiply it there. And then we're going to write these factors, x plus 2i, x minus 2i, x plus rad 2, and x minus rad 2. So how many factors do I have? 5, all 5 of them. Perfect.